Welcome to Rudy's Retro Intel. On today's show, we'll be looking at a Commodore PET 2001-8 motherboard. This was sent to me by a friend of mine and a fellow YouTuber, and apparently there's no signs of life on this. So let's peek inside and poke around. Stick around. Alright, before we get into the actual PET motherboard repair, I wanted to show you a couple of things first. This is the web page, or the YouTube page for Everything is Broken Garage. Ryan's done a whole bunch of videos on all kinds of different things. I would recommend checking it out. I will be leaving the actual links to these channels in my description along with other documentation, so check that out once you've watched the video and give it a thumbs up. Ryan has also included with the board these real-time clock modules. They're replacements for the dialless chips, which are widely used in the 46 and Pentium motherboards. So I'm going to be putting one together and try it out soon. Again, I will leave a link for the YouTube channel so you can watch how these are made and how they're used. This is the picture of the board that Ryan sent. It does not have the ROMs installed and the RAM also. He has provided the ROMs except for one, and most of the RAM, some of them are bad. We can see he's already replaced the character ROM with this modern replacement, which allows you to plug in a modern what's it called, EEPROM, and also a modern replacement for the video RAM. So this is the location of the video RAM. Here is the 6502 processor socket, but it's missing, and you'll see in a minute why the IC is missing here. Now, I have to give a big shout out to Chuck. Chuck has a great channel, a lot of great stuff on vintage Commodore PETs and other computers. So check out Chuck Hutchins' channel. Again, I will leave a link in the description. And I want to give a big extra shout out because he's helped me with some of the stuff that I've learned regarding this repair. So I have a I have a PET 4016 motherboard, and Ryan only sent me the 2008 motherboard, so I have no power supply, no keyboard, no video out. So I reached out to Chuck, and he said, yeah, you can actually take the connector from the PET 4016 and use that on the 2001-8. Now, here is the way you would connect it. These two pins are not used, and so need to be not to be connected. Here are the voltages, the ground supply, connections, and there's only 5 pins on, so it just plugs straight in, ensuring that the notch and these extra wires are not connected. And I put together this diagram after my repair to help you and others to repair your own Commodore PET 2001. Now, this picture was already on the net. I do not know who the original author of the picture is. If you do, please leave me a comment in the description. But what the person has done is they've put these circular-ish symbols around parts. So this is the voltage regulator 6, 5, 4, and 3. And it shows you which parts of the boards it powers. So for example, the purple one, the voltage regulator 6, powers this part of the RAM and this part of the ROMs. Voltage regulator 5 powers this part of the RAM only. Voltage regulator 4 provides this section of the RAM and TTL, and the 6520 and the additional support logic. Finally, the voltage regulator 3 provides power to this section of the board. And so this is great because when you're doing repairs, before you start, you need to check the voltages in random components in each section to ensure that these are working. You might have a PET that's partially working and you wonder, well, it's some kind of bad chip, but it could be a regulator that's broken. So for example, you could have voltage regulator 5 here, is defective and you're wondering why it's working but this part of the RAM is not. So excellent diagram. What I've done to this diagram is I actually added the labels. So this is the 6550 RAM. Again, this is all 6550 RAM. The order of the EEPROMs from H1 all up to H7. I've labeled this is the 6520, 6502 processor, another 6520. By the way, the 6520s are referred to as the PIA. So this is 1 and 2. 6522, the character ROM, and the video RAM. I've also added the labels for this is the IEEE port, the user port, tape port, memory expansion, and the voltages that you should be seeing on these pins for the power. So pins 1 and 5 is 16 to 18 volts AC. Pins 4 and 2 should be approximately 9 volts DC unregulated, and pin 3 is ground. Now, I also added one more thing on this diagram, was these red dots. These red dots indicate the notch of each chip. So it shows you the way they should be plugged in. So for example, here's 6502, the notch should be facing on this side. If it's facing on this side, then this IC is plugged in wrong. And I've made a note of that here. Also, some information regarding the ICs, what they are, and some ROM location, some information about that, and of course my YouTube channel and logo. So looking at the board, what I've done is I flipped the picture around so we can kind of match this picture with the picture of the board we got from Ryan. And yeah, so it's upside down, but you're getting an understanding of where everything is. Now I flipped it around one more time so you can read the numbers, the actual numbers for each chip prop easily. And I've noticed something right away. Actually, if you look here, for example, the 6520, the red dot is on the right, meaning this is where the notch of the chip is. And I've circled it on Ryan's board, and it's correct. So the orientation is here. This is correct. Let's see if we can zoom in on here. And we can see, yes, that's correct. So let's zoom out, and we'll look at the next one. This is the other PIA, the 6520. The notch should be on this side. But when we look on the board, the notch is on the wrong side. So right away we know that this IC is in backwards. It's not, the orientation is incorrect. So this should be on this side as to this diagram. And also note that the 6522 here has the notch on the left side of the diagram, and here it's on the right. So these two chips are in backwards and would be the first area that we should be exploring. And then later on, once it's all done, I will explain this sand incident regarding a short on the board that happened. So let's go back to the bench and take a look. Okay, so with the board here, we need to apply power. So I have a PET 4016. The power supply, as we saw, is compatible. So we can plug that into this spot here. Now what I've done, let's see if it's showing up on the camera. There, I've made a little red notch or marking with a pen. I've done the same thing on the power supply here, so I know that when I'm plugging this in, I'm plugging it correctly as per the diagram. Now what I'm going to do is turn this around this way so we can show you some other things we need to plug into. So we have power. Great. The next thing we need is this unit here, if I can get it detached. Okay. So what I'm going to be plugging in here is my Commodore PET companion board. This board allows you to plug into pretty much any PET. It gives you composite out, audio out, and a port that allows you to use your RGB to HDMI to actually get those signals from this unit. So that plugs in straight in here onto the user port. Now this piece here plugs into the tape port for power. If you're using composite, then you need to plug this in because the two logic chips on here need power to power up the composite out. If you're using HDMI, like if you have this adapter, you can buy them pretty much. I'll just search RGB to HDMI. It's basically a pie with some buttons on here for configuration and an SD card to store information regarding your configuration for each type of computer, and a port with a cable. So I'm going to be using this, and then you just basically wire it up properly, and then you plug it into this port on here, and now we have RGB to HDMI access. Now I'm using this because it's great for capturing video. If you use the composite out, a lot of the composite video capture devices don't like it. The signal's not maybe it's formatted not as well as it should be, or the signal isn't strong enough. I believe it's the frequency that's an issue, but that's fine. If you're just plugging into a monitor just for yourself, you can do that. But for recording video, I would use the RGB HDMI. I use it because I just love the clarity of it. So let's get this all connected. Let's do that. So give me a moment while I connect everything up. Plug that in there. Okay. So what I'm going to do is switch cameras. All right. Now we're going to power this up. Actually, before we do that, we need to plug in the CPU. Now the CPU socket is empty because Ryan has got this unit. This is a timeout software 6502 ROM RAM replacement board, and what you do is you pull the CPU out of your board and you pop it in here, and then with the dip switches you can configure. You can configure different configurations. You can use the onboard RAM and ROM. You can use the onboard RAM only and use the external ROM. You can use the external RAM and only the internal ROM, or you can use everything. Just have it use like bypass. You can select different versions of BASIC, 1, 2, and 4. Although this board does not support BASIC 4, you have to pick 1 or 2. And it's got also a built-in diagnostic, so it's kind of neat. Let's plug this in. Again, according to documentation, the notch here needs to go on this side towards me of the board. So let's plug this in and see what we get. All right, so it's connected. Let's power up. And this is what we're getting. This is what I was afraid of. Let's go full screen here. So as you can see, we are getting nothing. We're getting just random characters. Let's power it off, power it back on. We're getting random characters, although the characters look good. So that's a good sign. So let's power it back off and remove these two ICs. Ryan did also include, he had this ROM, character ROM or ROM replacement. You basically use an EEPROM to fit into this socket, but this ROM works fine, so I'm going to put the original one back in. Let's remove these two and use my own to see what is going on. I think these two might be dead because they've been applied power to in the wrong configuration. So this is the 6522, and make sure the pins are straight. Yep, plug that in. Again, make note that the notch of the IC is facing like the rest towards me. The next would be the 6520. I have another 6520 I have from another computer. plug that in there. Again, the notch is facing this way. One thing to remember on these boards, the only chip that faces the wrong direction, well, it's perceived to be wrong, is this one. This PIA, the 6520, is the notch is facing away or the opposite of these ones here. Why it's designed that way, I don't know. It's something that maybe Microsoft realized later was a mistake. This is the first version. This is a 1977 version board. The assembly model is 320008, and it's a PET 2008, not a PET 2008-N. That is different. Power is different. A lot of things are different on that one. So, anyways, let's power it on. Let's switch screens and power it on and see what we get with these two replaced. Oh, and we're getting cursor, we're getting everything. Look at that. So we have booted up into the basic, and it's 31743 bytes free, ready, and the cursor is flashing. Excellent. So with that, we know that was the problem. It's been fixed. This board does have external RAM. I am not using that. This is configured to use the RAM and the ROMs that are built into the unit. So you don't need ROM, you don't need to have any RAM, you can just plug this in. I think this is a great way to future-proof your Commodore PET, because the ROMs, you're going to need some kind of additional boards like this to emulate it, and then populate all the ROMs. The RAM, again, you need something like this to populate the RAM. I'm not sure if this would even, this should work fine. But you need to spend, a lot of money with, this part and this part to get it going. So I think it's better off just to, put this in, and then you can remove these. You can leave them on, but you can remove them, and, go from there. And you can just, again, switch it. So what I'm going to do first is I want to see if any of these RAM ICs are bad. So let's switch over to another diagnostic boards I use. Like, again, this is Ryan's. I'm going to show you the built-in diagnostics, how it runs on this later on, but I'm going to use my diagnostic board in here. So let's plug that in and see how that goes. Okay, so this board here is a time off software PET Diagnostics version 1.6. Let's see if that's showing up in the camera. Oh, there we go. And this board also has different settings you can change for different types of boards. The neat thing with this is that it boots up. It just falls in or pops into the CPU socket like so. Let's put that in, and that's it. The only thing it does is run diagnostics. It doesn't do anything else, and you can again set it for different boards. So let's power this up and see what it does. Now this is going to look for the external memory and ROM built in the board, doesn't have everything on board. What I'm going to do, you really can't see that very well, so let's switch screens. I'm going to switch over to a different setting and power it up. So we're powering up here. It's checking the processor, the reset period, IRQ, MRI. It's showing that the switch setting is for a PET. Now we can see here at the top that 1, 2, and 3, third row is good. The fourth row is only showing half good. When highlighted, it means it's not working. It's also checking, in this case, all the EPROMs. So I don't have them all here, so I'm not going to let that go, and that's fine. I just want to show you the built-in or the diagnostics board that I'm using. It checks the different video modes, and then it's going to go and repeat again. Here we're seeing the first 3 rows. Let's go back to this camera here. So the ones that are showing as good, they're fine. They're warm. Chips are getting warm. Are good. The one that's showing, so it's 1, 2, 3. So it's 1, 2, 3, fourth row. The bytes 0 to 3 are good, and 4, 5, 6, and 7 are bad because they are not populated here on the board. And yeah, so it's going to continue and just go through this, which is great because it'll just keep running the test until something fails. Here we're seeing that it's showing the ROMs. It's going to go through each ROM. It's saying that it's empty, and that's fine. We don't really care because Ryan wants to use this daughter board to run the PET, so that's fine. I just wanted to check this ROM. Running these tests, I did find a whole bunch of RAM. 1, 2, 3, 4, 5, 6, 8 RAM pieces are bad, so these can go bad. These are, again, it's 40-plus-year-old computers, so things can go bad, and these are very difficult to find to replace. So again, you're better off using that. So with that being said and done and tested, I'm going to power this off, and what we're going to do now is I'm going to pull this out. This pops out like so, and then this will go back in, being careful that it's going in properly. In this case, the notch with the CPU is facing me, so the board sits on this side. The rest of the board, the switch is there. What we're going to do next is I'm going to run the onboard diagnostics of this unit just to show you what it's like. So I've printed off the documentation, and it gives you all different switch settings for ROM and RAM, etc. And switch 7 in this case needs to be off, and we're going to put that to off. So now switch 7 is off, and we should be able to boot up and go into diagnostics. So let's switch screens. I'm going to switch to this screen here and power it up, and it's running through its built-in diagnostics. Yeah, the board will continue to go through, loop through the different diagnostics built in. What I'm going to do, I'm going to stop this here, and I'll show you the video in a moment with it fast forwarded to show all the tests that it's doing. What I want to do next on here is, well, we got the board up and running. It looks like it's working, but we don't know. Does the peripherals work? We need to plug in something to the IEEE port, and then eventually into the tape port, and make sure that's working correctly too. So what I'm going to do now is I have two different devices. I'm going to use this one for today because of the software on here. This is the SD to PET feature. It has the SD card. It plugs in. I showed this on the video that I created on my channel a while ago, not too long ago now, that talks about the tools that I use for doing repairs. Again, I don't need to have this plugged in, so I'm going to unplug it just to show you that you don't need to have the power plugged in when using RGB to HDMI. So let's put that to the side. Now, you do need power for the SD card reader, so we're going to plug that in, and then what I'm going to do is I'm going to turn the board around just to give myself a bit more space on the desk. Hopefully you can still see everything. Let me see if we can adjust that to make it a little bit better. Okay, so now with all this plugged in, great. Well, we need a keyboard, so what I've done is I've removed the keyboard from the PET 4016, and we can plug that in here. So this is keyed. There is a piece that's stuck. Let's see if it's showing up in the camera here. There is a piece that's kind of like blanked out, so you can't plug this in backwards. So what we're going to do is the notch is on this side, so we're going to plug this in. Okay, so now we can actually connect this up, and let's see the best way to set this up. I'm going to connect this up this way, and then we're going to power on. Now I'm going to switch cameras, so give me a moment here so we can get a bigger view of the monitor as I'm typing away. So give me a moment and we'll set that up. Okay, technical difficulties fixed. The PET SD card adapter, the SD card was the wrong one. I don't know why I put that one in there, but this was something else. Anyways, I put the right one in there, so now we can power back up. I've twisted the board a bit so you can see everything, and the RGB to HDMI. Where is that? In this area here, you're going to see what's going on a bit better as opposed to a small screen. Let's power this up. All right, so we're getting the command prompt. What I'm going to do here is we're going to type in SYS. Well, actually, before we do that, let me show you the load command. Comma 8. So it's load quote dollar quote comma 8. And if I do a list, there's everything on the SD drive. Now, the other command which comes with this is it's called the DOS wedge. So it's 9 times 4096. We type that in, and there we go. Now, if I do at dollar, we get directory. So I don't have to type in load blah 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 all the commands. And it's also listed in the documentation, so all the information, all the cool stuff. So for example, you want to just show how much free you have. You want to see any errors. That you can use the load command just by typing the up arrow. So let's find what we have on here, and something fun we can try out. Not all the games are going to work because the limitation of the basic. And let's see, what should we load up? Let's load I don't know, Galaga or Air Attack. Let's load up Air Attack. So we can go up arrow and then just put air and then start, because it's the only program that has the word air in it. So let's do that. Loading. And there we go. So it's the object of the game is to land an aircraft in New York City. To do this, you must destroy all the buildings first by bombing them. To drop bombs, press the space key. The aircraft moves on autopilot, so you only have to drop bombs, etc., etc. Let's try it out. So here we go. And I'm going to space bar. And yep, it's dropping bombs. Now, there's a lot of stuff to clear on here to land this thing, so I don't know if that'll even happen. But as you can see, it's actually up and running. I believe that this machine is going just fine. It's working okay. I'm going to test the tape port before I send it back to Ryan. But I'm going to show you one more thing that that happened while this repair was happening, which is very strange. I've never seen it happen before. And let me switch over to the desktop to show you exactly what the problem is, and then come back here. It's going to be very difficult to reproduce it, but something to watch out for. So let's switch over. So here's something interesting that happened during the repair. There's a couple of TTL logic that were questionable and needs to be replaced. And that's fine. That's normal. I'm not going to go through all that. This will be a 3-hour video of a repair. But one thing that did happen is that on the 6520 in the G8 location, I'll show that in a minute, PIA number 1, I kept finding a short between these two pins, the keyboard and the sync. And the computer was acting strange and wouldn't boot up properly. And so what I had to do was, I was chasing out different rabbit holes. I was checking out traces, where it's going to, and everything seemed to be fine. So I was getting very frustrated. I talked to Chuck. He's never seen this problem before. Like he mentioned, these two should not be shorted. So couldn't figure it out. So what I was going to do is pull out the socket and see if the short went away. But before I did that, let's switch to the other view. Okay, so before to do that, I was gonna pull out the. Let me just move some of the stuff out of the way. So I was gonna pull out the socket. The sockets on these Commodore units, computers, as most people know that done any repairs, are very low quality. Let's put it that way. I'm gonna say cheap, but yeah, they are. So let me see if we can zoom in a bit on here so you can see what I am talking about. All right, so the sockets here are single wipe, meaning that only one side of the IC. So if this is your IC, only one side is touching the connector, and they can get stretched and go bad and then not making proper contact. The newer ones are dual wipe, so that there's two locations where the pin is being touched on one side and on the inside, so it's touching in two places, making it better contact. These ones are cheap and garbage. Now couldn't find the short. I was gonna pull this socket out because I thought maybe it's a socket, but it was very strange because it wasn't a chip. It was definitely something on the board. So what I did is I figured, okay, let me try one last thing. I did use deoxit. I've mentioned in my other videos that I like using some kind of contact cleaner. I like the deoxit brand. So, I went through and I sprayed them all, and I did it to all the chips before I, continued or started my testing. But this one was done. So what I did is I figured, okay, let me try it again. And I sprayed it. But this time, I sprayed it further away. So it went under the socket. So all the contact cleaner fluid was flowing on top of the pin location for the socket, but also underneath. It was going underneath here, and it flushed the bottom side of the socket. And what happened is little bit of, I thought it was dust, but it was actually sand that came out. So I don't know. I think someone took the PET to the beach and had some fun, but finding sand inside the computer is not a good sign. Why there's dirt in here, I don't know. Anyways, once it was flushed out with the deoxit, I flushed it all out and I made sure I get all underneath this socket. Then it worked. That short went away and everything was fine. So I didn't have to replace the socket. Although I do recommend, I'm going to let Ryan know that if he's watching the video, you should be doing this, Ryan, is take these sockets, the CPU socket, these two sockets, this one, the 6522, the 6520s, the character ROM, the CPU for sure, and these two, and pull them out and replace them. Now, it's controversial. It's like, oh, you shouldn't be touching stuff if it's not broken. Yeah, you can leave it for now, but eventually you're going to have to replace those. So if you want to do some more future proofing on the PET, take your time slowly, remove them and replace them with proper modern sockets that aren't the single wipe. And that's what needs to be done. Other than that, the machine looks great. I'm going to be testing the tape port shortly, and then letting Ryan know that it's going to be in the mail and coming his way. Well, that's it for this video today. Hope you enjoyed it and you found some interesting information doing the Commodore PET repairs. One thing I did not mention is that the 6520, if you can't find that IC, you can use the WDC 6520-N. I'll leave information in the description of the video as to a modern replacement you can use for that, and that's, you can get your PET up and running. Big thanks to Chuck again. Big thanks to viewers like you and current subscribers, Patreon members. If you're a Patreon member, your name gets automatically added to the scroll bar down at the bottom. So if you want to see your name in some kind of fun fashion, please donate to the channel. Hopefully you get a thumbs up and you subscribe if you haven't. And yeah, hopefully this video will help you do repairs on your 2001-8 repairs. Again, thanks for coming. Take care. See you soon.